Okay, so let's get started. We're going to be taking a look in this tutorial at building our VCM scanner with certain math channels and making sure your chart versus time are in order so we can analyze better our GDI, gasoline direct injection, and port injection systems and how they're working in unison together, and evaluating the performance of each fuel system and seeing exactly what's going on within controlling your Gen 3 engine. This is critically important to understand if you're out of fuel on the low or the high side control, and judging what then you need to do, what some next steps you need to have happen. We're going to just prep everything in this tutorial in our VCM scanner to get things ready to talk about further in some future training tutorials here. So moving through some more programming topics with the GDI and port fuel injection and understanding is better. So we have to have our scanner in order to open up some sample data logs, even reviewing data logs that you may have on your end to understand and evaluate how things are working in your GDI and port fuel injection. So what I have open right now is the file from our previous tutorial. It's a stock equivalent file. It's a 2022 Mustang GT manual stock that's found in our training course folder. So you can go into the sample calibration file subfolder and open up any sample stock file. What I want to do here quick is just move into the engine tab, under general, under fuel, and then here under general. I'm just going to leave this open right now. This is going to be something we may reference back in this training module, because what we're working with in setting up our VCM scanner relates to programming both the DI-PI blending and something like our one-shot table that commands the start of injection point for our GDI system. Let's jump into our scanner so we can take a look at how we can prep things. Now, I've supplied everything in the training course folder for you. You just need to assemble the math channels to make sure they fall in line with the way I've created the VCM scanner layout. Otherwise, you may run into problems if you're trying to get something like the chart versus time or the table layouts to work correctly. This all hinges upon our math channels. So let's go and discuss what I've done, how to bring in your math channels specific so the scanner isn't broken, doesn't give you any problems, so you're able to open up data logs and being able to follow along with our tutorials here. Let's move into our VCM scanner, and what we're going to do here is make sure you have the HPT Gen 3 Coyote main layout option open. This is probably going to be the only layout I provide for this training course. I'm trying to condense down the available layout into just one single layout, so you can use this for working either in tuning a Mustang or an F-150, and just kind of keeping things more simplistic. If you've taken my Gen 2 training course, I had a whole bunch of different layouts open that are available you could open up in your software. And I find that if kind of narrowing things down and whittling things away, we can really get away with just one single layout. So that's kind of the goal for this training course. So we're going to be opening up our Gen 3 Coyote main layout option, which I have open right here. Now, if you take a look here, we're going to find that we have tables like the F-150 SD slope, for example, or F-150 SD tuning, or one-shot, which is that one-shot start of injection table. Some of these tables require us to have specific math channels or parameters that we can plot into these table overlays here. So let's move in here to tools. We go down here to math parameters. This is what you need to have loaded into your VCM scanner software. In this specific order, the order is critical in order to make sure that your table overlays and chart versus time here work correctly and they're not broken. So for example, if we're taking a look at this last chart versus time, or the second to last chart versus time, for example, we're going to find these channels CA Spark, CA IVC, CA SOI. We're going to talk about what those actually mean, those abbreviations. But in order for these channels to actually work, two things have to be true. One, we have to be logging that channel data in our PID channel list. Two, the math channel that we populate in here has to match in the specific order that we're calling it out here for that to exist in our chart versus time or into a table overlay. So for example, if I'm looking at something like my CA Spark, this is going to be short for cam angle spark degrees. And again, we'll talk about what this represents. it has to be loaded in the order here. So this is the 1, 2, 3, 4, 5th option in my math channels list. The way that the scanner software works, which is pretty annoying, is that if you're adding in a custom channel, custom math channel in your math channels here, and you're calling it out in your table overlay or in your chart versus time, it has to exist in the same exact math channel orientation here in your list. This starts at math channel 1, so we can see our user math. We go down the list here, see there's 18, 19, 20. Well, this is user math 1, user math 2, user math 3, user math 4. In order for anything to exist in the chart versus time or the table overlay that calls on these math channels, it has to be in the exact order. So when you're opening up your training course layout here that I'm providing, in order for everything to work, you need to load these math channels in here first, in this specific order. So looking at this, in order to load a math...
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here. And you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.